Hi, in this video I'll take a look at just working with radian angles some more. The first problem here, it asks us to find angles that are shown between negative 2 pi and 2 pi, and it's saying assume the marks are special angles. So what are our special angles? Hopefully you remember 30, 60, 90, 45, 45, 90. And if we're going to think about those in terms of radians, then let's do that. 30 degrees, do you remember? Pi over 6, 60, pi over 3, 90, pi over 2. 45 then? Pi over 4, pi over 4, pi over 2. All right, so if these marks are special angles, this first mark, second mark, third mark, maybe it just takes a little time to get used to, I don't know, but if we look at that, you see it splits the 90 in half. So that's pi over 4. And then the other two marks here, they split the 90 into thirds. See that? So this ends up being 30, 60. Oops. Don't know where the 36 came from. 30 and 60, which is pi over 6, pi over 3, and then this is pi over 2. So this is helpful if we keep this in mind. I don't know how you want to do this exactly. We need to find m, actually all the letters. So I'm going to keep doing it in terms of 6 since I already have these drawn out. You'll notice that the pi over 6 and the pi over 3 relate. They overlap. And so I can see m here. If I think of this as pi over 6, pi over 6, pi over 6. So this is pi over 6, 2 pi over 6, 3 pi over 6. M then is 4 pi over 6. So m, 4 pi over 6, which if I reduce is 2 pi over 3. So that angle is 4 pi over 3. I can see I have Q here. I could keep going around the circle and counting that way, but it's actually a lot easier just to go backwards. So Q is negative pi over 6. So Q is negative pi over 6. Now we have to find P and N, and you can see those are a little bit different. So I'm going to go ahead and delete these out. To get P, we see we're in the 45 multiples of 45. And so this is pi over 4. If you want, you can just count. This is 2 pi over 4, 3 pi over 4, 4. You can just skip, right? We know that's pi, so this has to be 5 pi over 4. Q, I said, was negative pi over 6. Maybe I'll just mention, if this is 2 pi, we know that's 12 pi over 6. So this would be the same as 11 pi over 6. That's for Q. And then N. We need N yet. How do we find N? Well, it's really not too bad. You could think of this in several ways. You could see we're working with multiples of 90, so you can think of this as pi over 2, 2 pi over 2, 3 pi over 2. That works pretty good. You could also think about going backwards 1. That's the same as negative pi over 2. Either of those would work for n. And so that's just working on the unit circle with the angles. It's going to be really useful and important for you to be able to do that in the future. Let's take a look at the next section here. We need to find a positive and negative coterminal angle. Do you remember what coterminal means? It's the same terminal side. And so here we go. How did I do that? Remember, if I had an angle, like, say, 20 degrees, how did I get another coterminal angle? We just added 360, right? Well, now we get to think in radians. I've got an angle, 3 pi over 4. You don't even really have to find it, but it ends up being over here, 3 pi over 4. How do I find a positive and negative coterminal angle? Well, I can just add 360. But wait, we're not in degrees anymore, we're in radians. So I can just think of it as adding 2 pi. So 3 pi over 4 plus 2 pi. Need common denominators. 3 pi over 4 plus 8 pi over 4. Multiply top and then the numerator and denominator by 4. That gives us 11 pi over 4. So 3 pi over 4, 11 pi over 4. Now the other way I can do this is to subtract 8 pi over 4. So if I take and I subtract 8 pi over 4, that's going to give me negative 5 pi over 4. And so two coterminal angles with 3 pi over 4, one positive, one negative, is 11 pi over 4 and negative 5 pi over 4. And that's coterminal angles. I will hit the complement and supplement. Do you remember complement means corner? So two angles make up a corner. Supplement, straight line. Two angles make up a straight line. So 3 pi over 8, we could sketch that. I'm not going to worry too much about exactly where it is. It's a small angle, less than pi over 2. I'm thinking 4 pi over 8 would be straight up and down, so actually my angle's not in a very good spot. Should be more vertical, but we can live with it. Complement. I need to find the complement. So if it's going to make a corner, this is pi over 2. What is this angle here? Well, if I think of pi over 2 as common denominator with 8, I need to multiply the top by 4. Gives me 4 pi over 8. So I just need to subtract now. 4 pi over 8 minus 3 pi over 8 is pi over 8. So the complement is pi over 8. How about the supplement then? The supplement, we just need to find it here. What is this angle? Well, we know this is pi. Again, common denominators. I want to find 8 pi over 8 and subtract 3 pi over 8. The supplement then is 5 pi over 8. So again, just working with radians, one of these key ideas you see that keeps popping up is common denominators. Getting common denominators, looking at parts of a pi. And so this actually has more to do with fractions than it is with angles. So let me know if you have questions.